All right, let's start off chapter 9 with a little functions review. The first two questions here are asking you to get the definitions of domain and range, and this should be right out of your notes. Basically, the domain is a set of all x values in a function. And the range is a set of all y values in a function. For numbers 1 and 2, we're going to find the domain and range of the relation and put them in both list form here and then in our little Easter egg circles here. We're going to draw a mapping connecting these together and showing the relationship. And finally, we're going to graph. So for number 1, we're going to start with -3, -4. So if I graph that, I would go left 3 from the origin and then down 4. So that would be right here. My x value is one of my domain sets, so -3. And I'm also going to go ahead and add him to my domain Easter egg. My y value is one of the range sets, -4, and I'm going to add him to my -4 range Easter egg. The next point is -1, -3, so I'll go left 1 and down 3 on my graph to put a dot. I will steal the x value for one of my domain lists, the y value for one of my range lists, and I'll add those to the Easter eggs as well. Next, I have the point 0, -1. So that is right there on the graph. The 0 would be in the domain, and the -1 would be in the range. Next, I have over 2, up 3 on my graph. The 2 would go in my domain, and the 3 would go in my range. I forgot to add the -1 in my range from before, so I'll just add that guy now. Perfect. Okay, and then I have over 2, up 5, which is right here. Now remember that we don't want to list this 2 a second time. We've already listed the 2 in our domain, so I'm not going to list it a second time. That means my domain is done, and so is my domain Easter egg. The 5 has not been listed yet in the range, so I'll add him to my list of 5. And make sure he's in the Easter egg as well. We're almost done with this. We're ready to map. So it says here that -3 maps to -4. So over here, -3 must go to -4. I know that -1 goes to -3, so I'll add that in. I know that 0 pairs with -1. I also know that when I plug 2 into the function, I get 3, so 2 will go to 3. But then here's the issue. When I plug 2 in, I also get 5. This is a problem. When I have a split or one member in the domain going to 2 different members in the range, that means this guy is not a function. So later on, it's going to ask us if number 1 is a function or not. You can see right here it's not. You can also see right here in the graph it fails the vertical line test. So let's just make a note of this for later, not a function. And you can see that here, and you can also see it in the graph. Let's check if number 2 is a function. We're going to do the exact same thing. Let's state the domain. I'm just going to do the domain first. I have -5 from the first point. I have -4, then 0, then 1, then 2. If you notice, I just got those guys by stealing the x values of each of the coordinates. I'm going to list the exact same numbers in my Easter egg here. It doesn't really matter the order in which you list these as long as you don't repeat yourself. Let's do the same thing for range. My range would be -4, 2. I don't want to say that 2 again. I've already listed it. Then 3, then 5. So the set of -4, 2, 3, and 5. Again, please don't list the 2 twice. -4, 2, 3, and 5. Let's go ahead and draw our mapping. When I plug in -5 into this equation, I get -4. When I plug in -4, I get 2. When I plug in 0, I get 2. When I plug in 1, I get 3. And when I plug in 2, I get 5. To graph this set of points, the first one I would go left 5 and down 4. So that would be like right here. And then I'm going to go left 4 and down and up 2. So that would be right here. Then I'm going to go over 0 but up 2 right here. And then I'm going to do over 1 up 3 right there. And finally over 2 up 5. So to test if this is a function or not, we can check to see if the vertical line test passes. No matter where we look, if we draw a straight line, we will never hit more than one of these dots at a time. Okay, remember this is a vertical line test, not a horizontal line test. In other words, just because these guys are on the same horizontal line, it doesn't matter. Same thing here. I can check my Easter eggs. As long as all 5 of these numbers only go to one number in the range, then we're in good shape. It looks like the -5 only goes one place, the -4 only goes to one place, the 0 only goes to one place, the 1 only goes to one place, and the 2 only goes to one place. A lot of students get confused because they think because this 2 in the range receives 2 different domain answers, that this is not a function. However, we don't really care about the range when we're deciding if something's a function or not. We only look at the domain. So all of these guys only pair with one member in the range, so this yes is a function. Okay, let's go ahead and define the function as a relationship where all the members in the domain map to one and only one member in the range. We already talked about these next two things, if number 1 is a function and if number 2 is a function. We talked about how number 1 is not a function because the 2 in the Easter egg maps to 2 different spots in the range, and how number 2 is a function because we don't have anybody over here mapping to 2 different places. So here are my written out answers for number 1 and number 2 function questions. If you'd like to pause the video to read those out, this would be a good time to do that. All right, let's take a look at the back side. For the next couple questions, we're going to determine whether they're functions and then explain why or why not. Here, you can think about you can go ahead and draw the Easter eggs if you'd like, but another way you can think about this is seeing if any of your domain repeats itself. Because if it did, it would be listed twice in that domain Easter egg, and therefore it would probably go to 2 different places. So, if we look at number 3, we've got a -4 in the domain, a -2, a 0, and a 1. We never repeat a domain, so therefore the range is good to go. This is yes, a function, because none of the domain repeats itself, so I won't have any issues. Contrary to that is number 4. If you look here, I have a domain of 1 and then a domain of 1 again. So this domain of 1 maps to 1, while this domain of 1 maps to -1. Think about just those 2 values in our Easter eggs. I have the domain of 1, so I'd only list that once here, and then I have a range of 1 or -1. Here's the issue. This guy sends that guy to a +1, while this guy sends that one to a -1. See how we have an issue? So therefore, number 4 is not a function because 1 maps to both +1 and -1. In number 5, we already have the Easter eggs drawn. I would just look at the domain. They look like they each go to individual places. So I have to say yes because all of the domain members only go to one member in the range. Number 6 looks like we have an issue right here. This member in the domain splits to 2 different members in the range, so this is not a function because 0 goes to both -1 and 0, so this is not a function. On number 7 and 8, I would check with the vertical line test. It looks like no matter where I draw a vertical line, and even though I can't draw them very straight, no matter where I draw a vertical line, I'll only be intersecting that graph at one point at a time. So this would, yes, be a function, and you can say because it passes the vertical line test. We can run that same vertical line test on number 8, and you see, like for example, this vertical line right here will make this fail the vertical line test. I pass 3 times through this vertical line, so no, this is not a function because it fails the vertical line test. Okay, it's as simple as that. Next, we're going to just do some evaluating. We're going to take all of these individual functions and plug in 6 to see what we get. Make sure you use correct function notation for this and simplify as far as you can go. So what I mean by correct function notation is I'm going to continue to write f of, but now we're plugging in 6 for x. So that means I have to take this x and replace it with a 6 and then times it by 2 and subtract 15. Remember, you're only solving on the right-hand side here. So I would have 2 times 6, which is 12, minus 15 is the same as f of x. So then to finish, we would just continue combining. Remember, we'll leave that f of x alone on the left-hand side, but on the right, 12 minus 15 gives me negative 3. So when you circle your final answer, make sure you have this function notation. This function notation right here says, hey, look, I took the function whose name was f, I plugged in 6, and what I got was negative 3. If you just write negative 3 for your answer, you won't get full credit here because that doesn't mean anything to me. I need to see f of 6, or in other words, I plugged 6 into the function f and I got negative 3. This entire thing is your answer. On number 10, we're going to take a different function f and we're going to continue to plug in 6. So instead of saying x, I'm going to write parentheses 6. So f of 6 here will give me negative, and then I have 6 plus 3. So negative 6 plus 3 is going to give me negative 3. So f of 6 equals negative 3 in this case. Number 11, we're going to plug in 6 into g. So we'll take g of 6, and we'll write it as 2/3 times 6 minus 1. With fractions, multiplying fractions, make both numbers a fraction, and then you can look to cross-reduce. This 3 goes into the 6 one time, so this is 1 time here and then a 2 times there. Cross or multiply straight across, and we get g of 6 equals, that 2 times 2 is going to be 4, and then minus 1, g of 6 altogether is going to be 3. Again, 2/3 times 6 over 1. I can cross reduce 3 and 6. 1, 3, 3 goes into itself 1 time, 3 goes into 6 2 times, and then we multiply straight across. So 2 times 2 is 4. On the bottom, 1 times 1 is 1, or just 4. That's how I got that 4 right there. All right, let's take a look at number 12. We're going to do the same thing. We're going to plug in 6 into h. So h of 6 is going to equal that negative 1/2, I'm sorry, times 6, and then minus 1/2. For this one, just use logic. What's 1/2 of 6? Well, that's 3, so I'll say negative 3 minus 1/2. Negative 3 minus 1/2, since these are both negative, it's like we're adding, so that's going to be like 3, it's like saying negative 3 and more, 1/2 more is negative 3 and 1/2 altogether. You can say 7/2 or 3.5 as well. Those are the same number. All right, this one we're going to plug in 6, so g of 6 is going to equal negative 6 over 6 plus 3/2. Well, so now we need to combine these two numbers. Remember that negative 6 over 6 is just negative 1, because 6 over 6 is 1, and we'll keep that negative. And then we need to add 3/2. Now it's your choice here. If you're tough with fractions, as fractions are tough, you can go ahead and try to make a common denominator and add these two together, but let's just try to logic our way through this. 3/2, another way to think of 3/2 is 1.5, right? 1.5, because I have 1.5. Well, I need to basically take away 1 from that, so wouldn't my answer just be 0.5 or 1/2? I think g of 6 is just 1/2. Okay, if you struggle with that, remember you can use your calculator. You can type this into your calculator. It shouldn't be a big deal. All right, the next one I would use a calculator with. It is a decimal question. It's up to you though. We have h of 6, so we're going to plug in 6. And that's going to equal negative 0.1 times 6 and then plus 2.1. And if I use my calculator or if I use my brain, either way, negative 0.1 times 6 is negative 0.6, and then I need to add 2.1 to that. So that's the same as saying 2.1 minus 0.6, which of course is 1.5. For the last one, 15, we're going to plug in negative 8. So f of negative 8 will be 4 times negative 8 minus 2. 4 times negative 8 is negative 32. Minus 2 is going to give me negative 34. Make sure you have your function notation for that, so I know that you took the function f, plugged in negative 8, and got negative 34. For g of negative 3, we'll take negative, again, the negative from here, and then we're going to plug in negative 3 into an absolute value. So remember, absolute value tells you the distance away from 0, or in other words, it gets rid of the negative sign. So this number here would just be positive 3. However, we still have a negative out front, and then we're going to add 3 to that. Well, what's negative 3 plus 3? It's going to be 0. G of negative 3 is 0. Last one, fraction. N of negative 2 is going to be the same as sticking that negative 2 in for x. And then, of course, we'll have to add 1. A negative times a negative, it's going to be positive. What's 1/2 of 2? Well, it's 1. So it's going to be positive 1 for the first term plus 1. So that's going to be n of negative 2 equals 2 altogether.